Hello everyone and good morning. Welcome to the OneClass channel. My name is Rome. I'm an honors Bachelor of Science graduate, currently working towards medical school. Today I'll be doing my best to go over some commonly asked chemistry questions at both the high school and college levels. If you need some homework help or tutoring, or just further clarification on the topics we covered today, please check out the links in the description below so that way you can get some nice professional help offered by one of our tutors here. With that being said, let's hop right into the session for today. And we're going to start with question number 1. What is the molar mass of glucose? Okay. So we have question 1 for today. Molar mass of glucose. So for these type of questions, the good news is that they did give you its the formula, the atomic formula here. Okay, C6H12O6. It's important to find the molar mass that you add the atomic mass units of every constituent. So as you can see here, for glucose, it says that we have 6 carbons, okay? And we have 12 hydrogens, and then we also have 6 oxygens, okay? So with that, we would actually go to our periodic table. It's important that you use the periodic table given to you, or at least if you weren't given one, make sure you keep using the same one and you're constant with it, because some periodic tables do vary slightly on the atomic mass units, and it's just important to be consistent. So we'll start with the carbon, okay? We have 6 carbon. So the carbon's atomic mass unit is 12.011, okay? Hydrogen is 1.008, and oxygen is 15.999. Alright, so I put the multiplication there is because I want to do 6 of the 12.001. So for glucose, that means carbon would contribute of its whole molar mass 12.011 times 6. So we have 72.066. That is how much all the carbons in glucose contribute. Hydrogen, we will now multiply the 1.008 times 12. That would be 12.096. And then we do the same thing for the oxygen, 15.999 times 6. And that would be 95.994. Okay? And here is where we would add them all up together so we can get our total molar mass, because now we've factored in every constituent in glucose, okay? So that's plus 12.096 plus 72.066. So the total we get for glucose when we add them all together is 180.156. But we're not done yet, because the molar mass, this is a representation of how many grams typically per 1 mole of the substance. And 1 mole of glucose, as we've covered, has 6 carbons in it, 12 hydrogens, and 6 oxygens. And the reason why I mention this is because the units are important here. It's not just going to be just this number. We have to put the units of grams per mole. This right here is the molar mass of glucose. It would not be the molar mass without the units, because this is what we would be using if they said find, for example, the moles of glucose based on this mass. You would need the molar mass to be able to convert it from moles to the grams, or grams to moles and vice versa. So with that being said, we'll look at our choices here. As I said earlier, the periodic table does vary, so it's important to pick the answer that's the closest to it. So based on the choices we have here, the molar mass of glucose, the best answer would be E. Okay, the 180.00. Only because it's the answer that's the closest that we can pick from. How did they get it? What they probably did here was they rounded the carbons to 12, the hydrogens to 1, and the oxygens to 16. Only because of the fact that, considering that some periodic tables do have that, they would have carbons, atomic mass units of 12, hydrogen would be 1, oxygen would be 16, and if you just did the same thing and multiplied it, you'd get 72 plus 8 plus 16 times 6. Whoops. It's 12 hydrogens, sorry. 72 plus 12. And exactly, you do get exactly times 6 times 12 times 6. So that would be, you do actually get 72, 12, and 96, and all this does indeed add up to exactly 180. So that's most likely what happened here. But let's see what we have in terms of what our professional, how they solved it. They did have carbon, they said 12 units, hydrogen was 1, oxygen 16, and they multiplied the constituents like we did up here, and then exactly that's how they got 180 grams per mole. So once again, I do stress it's important to go through the periodic table and just be consistent in the one you've selected, because for these type of questions, even though you may not get exactly the answer, you should always fall really close to the correct one based on the periodic table you're using. So now